Well, this looks like a fun problem. We got two graphs here, and we want to see which equation corresponds to which graph. Well, notice that both of the equations have an a equal to 3. That corresponds to the y-intercept on the graph, which is 3. So that's interesting, but it's not going to help us solve the problem. We need to look at the growth factor. Different growth factors, and notice that the graphs have different shapes due to that. Well, there's two different ways we could solve the problem. One is to compare the graphs to this flat line, which has got equation y equals 3. Now that's not an exponential function, it's a linear function. But we could write it in this form, couldn't we? Because whatever value of x you put in, you're going to have 1 to the x power, which is 1, and 1 times 3 is 3. Now going back to the graphs, whichever graph is closer to that flat line will have a b value closer to 1. And there it is. The red graph is flatter. It's closer to the line y equals 3. Its b value is closer to 1 than the other graph is. So that leaves this blue graph as y equals 3 times 0.5 to the x. So that's one way of working out the problem. Another way is to make a table of values here and find a couple of numbers using the equation. So I'll use y equals 3 times 0.8 to the x power and put a couple of values in our table. When we put 0 in for x, of course, we get 3 for y. When we put 1 in for x, we'll have 3 times 0.8 to the 1 power, which is just 0.8, and that leaves us 2.4. Now with the other equation, when we put 0 in for x, we also get 3 for y. When we put 1 for x, we get 1.5 for y. So if we compare these two numbers, these 2 points, which one is decreasing faster? Obviously, it's this one. This one's coming down faster. It's going down to 1.5, whereas this one's going down to 2.4. So this is going to be the equation with the steeper curve on the graph, and it corresponds to the blue one. You can see that pretty clearly on the graph.